All right, let's go ahead and continue forward. I was noticing in my last answer, I did mention it real quickly, but I do need to label these things as feet. These are displacement and distances. Feet. So that's feet distance. All right. So again, one more time with this right here. Let's go ahead and find the net change. And so the net change in position is an integral of its velocity. All right, so here it's going from 1 to 4. And I'm going to label this in case the reader doesn't know what this means. All right, so the integral, this is t to the negative 1/2. So this is t to the positive 1/2 times 2. All right, and so this is being integrated from 1 to 4. And so this would be, should have taken the 2 out. So this is square root of 4 minus square root of 1. All right, so the net change in position is gosh, I keep forgetting, feet. Not going to pass the AP test that way. All right, so I see that I have a critical point of velocity at 0. So if velocity is 1 divided by the square root of t, I see that I have a critical point when t is equal to 0. However, I notice that is also not on the realm of 1 to 4. So when I'm testing this time and velocity, I'm only interested in the interval that I need to know, 1 to 4. And I see in the value of 1 to 4, the velocity is obviously going to be positive. So that means that this velocity never decreased. You never had a negative area negating a positive area kind of concept. You never had that. So what this is saying is that the net change is equal to the total distance. The net change is equal to the total distance because there was no negatives canceling anything out. So this is also equal to the total distance. Okay, because there was no negative movement. It was all moving to the right, no matter what. It was always moving to the right. There was no movement to the left. Okay, particle moving on the x-axis, right is positive, left is negative, is given by this. This is the position. So what is the total distance traveled? Okay, so let's go ahead and figure out the velocity of this thing. So the velocity is a derivative of position. So this is 3t squared minus 12t plus 9. All right, and so let's find critical pieces of this. Again, we are only interested from 0 to 5. However, 1 and 3 do fall on that. And I see that the velocity is going to be, what, positive, negative, positive. Okay? Okay. Now, if I were to integrate from, for instance, like 0 to 1 or something like that, I do any integration of this velocity, what that does is it bops it back down to the position. However, it's close to the position, but it does not have the constants at the end. So if I integrate, and it's a definite integral that this is, it would be, I would get an answer t to the third plus, minus 6t squared plus 9t. That's what I would get, and that's the thing that I put the brackets on. So the integral of velocity, which I'm going to be doing here to find a change in position, I am going to see that, but it won't have that minus 2 at the very, very end of it. Okay, so again, I'm just going to write what I just kind of said. So the integral of velocity, which I'm going to be taking here real quick, is equal to the position without that end constant, without the end constant, so without this minus 2. All right, so what was the total distance traveled? So we begin off, the total distance is equal to the absolute value of velocity. So in this case, it begins us off with a positive distance. So that will be a positive integral from 0 to 1 second, or 1 minute, or whatever it is, unit of time, 1 unit of time. And then it turns negative, so I'm going to minus that, so now it's a positive, and that's going to exist from 1 to 3. And then it turns positive again, and we're going to take that to the full 5 minutes of time there. And again, the integral of velocity is the position without that minus 2. So why I'm saying that over and over again is because now I have to actually take this integral from 1 to 0. So where am I plugging the 1 and 0 in? Well, I'm plugging it into this position formula without the minus 2. So for instance, 1, I'm going to plug in 1. And that's x to the third minus 6x squared plus 9x. Again, without the minus 2. Minus that at the 0 and 0, 0, 0 is 0. Minus integral at 3. So that's the position at 3, again, without the minus 2. So that's going to be 0 minus 1. 1 was 4. So you see how that had a negative distance there, but with that minus, that's going to now be positive. So plus the evaluation at 5 is 20, minus the evaluation at 3, which was 4. 3 was 4? Yeah. No, 3 was 0. So this is 4 plus 4 plus 20. The total distance moved was 28 like units of distance or something. I don't think they gave you a unit like a foot or a meter. So okay, water flows from a storage tank at a rate of, okay, so this is the rate. So kind of think of this as being a velocity. This is a rate. Liters per minute. Find the amount of water. The amount of water is kind of like a position. Find the amount of water that flows out of the tank during the first 18 minutes. So the first 18 minutes would be from 0 to 18. All right, so they want to know what is the net change in the amount of water. And again, to get a net change, you take an integral of its rate. So we're taking the integral from 0 to 18 of the rate. So this is going to be 500t minus 5 over 2t squared. And so at 18, this is going to be 8,190 minus 0 for the evaluation at 0. So this is 8,190. And again, that was a change in the amount of water, and these are in liters. Okay, f of x is equal to x to the third has an average value of 12 on the interval from 0 to k. And what is k? All right. All right, here we go. So average value is the rectangle. So the rectangle goes from k to 0 of the average value. And they say that the average value is 12. And that's going to be equal to the integral, the value of the curve from 0 to k of x to the third. So the area of the rectangle is equal to the area of the curve. All right, so this is 1/4 x to the fourth from 0 to k. All right, so 12k is equal to 1/4 k to the fourth minus 0. I'll put minus 0 to make it look like I didn't have a problem. All right, so this is 1/4 k to the fourth. So I'm going to divide by k, multiply by 4, so I'm chilling now with 48 is equal to k to the third. So the cube root of 48 is 3.6342. Is again the third root of 48. Okay, what is the derivative of this? So what I'm kind of considering this is f is equal to 0x squared e to the t squared dt. All right, so what I'm going to do is I'm going to make u that top portion, and that makes the derivative of u equal to 2x. Right? So this is now u up on the upper bound. So ultimately what I'm going to be doing is I'm going to take d of f, that's df dx. df dx is going to be equal to df du times du dx. This is the same thing saying the derivative of f, that first portion. So df du. df du would be d du of f, which again is the integral from blah, blah, blah to u of e to the t squared dt times du dx, which came out to be as 2x. Okay, so this is just replacement of u, so it's e to the u squared times 2x. U being x squared, so u x squared squared is x to the fourth. So the answer is e x to the fourth times 2x. Okay, acceleration, velocity, position. I take a derivative going up, and I can take an integral going down, all right? So if I need to estimate the acceleration at time 25, and these are velocities, what I'm going to do is I'm going to take a derivative of that. And so the derivative is going to follow the mean value theorem, where I don't know what the derivative at 25, what the velocity at 25 is, but I'm going to say that that is equal to the average rate of change. And so I narrow the framework as close as I can, and I'm going to take a look at the framework from 20 to 30. So what I'm going to say is the instantaneous rate of change, the velocity instantly at 25, is going to be equal to the average rate of change, and that'll be close enough. So this is the mean value theorem. And so, yeah, because the acceleration is the derivative of velocity. So that is AKA the instantaneous rate of change, AKA the acceleration. Okay, and so the average rate of change in that realm is 140 minus 105 over 30 minus 20. Use a left-Riemann sum to approximate the value of that. All right, so the left-Riemann sum with 3 sub-intervals from 20 to 50. So 20 to 50 has, yes, 3 intervals. Has 3 intervals from 20 to 50. So 20 to 50 of this velocity using the left-Riemann sums. The first has a base of 10, the second has a base of 10, and the third has a base of 10, so that's good. So the left-hand y values are 105, 140, and 165. It does not include the 195 because that would be a right hand. Okay, an integral of velocity is a position, and so this is going to be feet. Okay, explain the meaning of the integral. Explain the meaning of the integral. So what happens what is an integral of a velocity? Well, that is a net change in position. From time 20 to 50. That's a net change in position. Okay. Evaluate 20 to 50, the derivative of VT. All right, so again, this would be 20 to 50 of acceleration. Or in essence, this is a rate of velocity. So a derivative of something, like if I take a derivative of position, that's velocity, correct? And this is a rate of position. So if I take a derivative of velocity, all right, this is a rate of velocity. Right, so this is a rate of velocity. So what would that be equal to? What is that equal to? A rate of velocity. If I take an integral of a rate, it's the change in this case, velocity. Just like above, it was a change in position. This is a change in velocity. So a change in velocity from 20 to 50. So 50 has a value of 195. And 20 has a value of 105. And so that is 90. Again, this is a velocity, so this is what? V per second. Feet per second. What is this? This is a net change of velocity. I think the book says it's like the average something. It's not the average. I think I even mirrored that on the answer key. It's not. Right? It's the net change of velocity. That's what it is. Estimate the average velocity of the train over the 60-second period, assuming using a midpoint Riemann sum with 3 subintervals. All right, so the average velocity, okay, is on a time frame from 0 to 60 of the average value of an integral from 0 to 60 of the velocity itself. So FC is that average value. Now, how do I take this integral when I don't have an equation to really integrate? Well, they tell you that this is the same thing. Well, this is approximately going to be the midpoint Riemann approximation. So we have to make that is going to be the MRAM. So the integral, that those Riemann sums are an approximation of the value. So 3 subintervals going from 0 to 60. That would occur intervals if I'm going from 0 to 60. There is my interval of 1, 2, and 3. So if I'm taking the midpoint of these midpoints would occur at 10, 30, and 50. Those are going to be the heights of my rectangles. The value at 10, the value at 30, and the value at 50. Those are going to be the heights of my rectangles. So notice how they all have a base of 20, so I'm going to start setting up a problem. All right, and so this is approximately going to be a height of 20, or excuse me, a base of 20, and heights of 10 is 45. Midpoint is 140. And 50 is 195. So that is in essence my integral. This is the average velocity. So this is, again, I totally forget, feet per second. Now, this is the never-ending assignment. So here we go with acceleration. Find the average velocity of the particle. All right. Okay, so again, I'm just going to kind of keep my mind straight. Okay, I take a derivative going that way, and I take an integral going that way. So if I have an acceleration, I can figure out a velocity. All right. So they want to know the average velocity, however. Okay, whatever. I'll figure it out. All right. So right now, the acceleration of this particle is 2t minus 6. So that implies that the velocity of this is the integral plus c. They do give me an initial value, so they give me a time of 1. And that is equal to 3. So 1 minus 6 is negative 5. C is equal to 8. So the velocity of this is p squared minus 6t plus 8. Okay, that's the velocity equation. All right, so if I'm after the average velocity, that would be on the time frame from 6 to 0 of the average value, and that's going to be the integral of the velocity itself. That will give me the average velocity. So I integrate velocity. This is going to be time to the third, excuse me, where 1/3 time to the third. Minus 3t squared plus 8t, and then usually that's a plus c, but because it's a definite, we're going from 0 to 6. And I'll bring over the 6, so that's 1/6, and that's going to be equal to my average value. So the evaluation at 6 1/3 x to the third minus 3x squared plus 8x is 12. So this is 12 minus 0, and this is 1/6. So this is going to be 2. So the average velocity in this situation, I don't think they give me any units, so I'll just say generically is equal to 2 units per unit time. So that's my average velocity. When is the particle moving to the left? Okay, right is positive, left is negative, and again, velocity determines direction. So this velocity I set equal to 0. And so this is going to be what? -2 minus 4. And so that's going to be +2, +4. So how does the time affect velocity? And again, we are on a time frame from 0 to 6. I have critical values of 2 and 4. So if I plug in a very, very small number, that answer is going to be positive, negative, positive. This is asking, when is this thing moving to the left? That would be when this is negative, and that would be time is from 2 to 4 seconds, or whatever the unit is. Okay. Y velocity is less than 0. So find the total distance traveled. So total distance is the integral from 0 to 6 in this case of the absolute value of t. So getting done with the problem that I just did, I know when this is moving right and left, et cetera, et cetera, et cetera. So this would be equal to the integral from, it's positive, so it'd be 0 to 2 of this positive. Then it turns negative, so I subtract to turn it positive from 2 to 4. And then it's positive again from 4 to 6. As such. And I already figured out the integral. That is the value of what is on the inside of that. That's the integral of velocity. So let's go with 2. Plug it in, so that's 1/3 x to the 3rd minus 3x squared. Yep. Plus 8x. So 2 has a value of 20/3 minus the value of 0, which is 0, minus the value at 4. (16/3) minus the value at 2, which was 20/3. So notice how that is negative. So, but now it's positive because of the minus. And then the evaluation at 6 is 12 minus the evaluation at 4, which was 16/3. Putting it all together, (44/3). It's the same thing as 14 puts into use, depending upon if you're allowed to use a calculator or not. At which point is the particle farthest left? and I think the book actually gave a false answer. Farthest left means a max, or excuse me, not just a min, but an absolute min. So what I need to do is I need to test all the points from 0 to 6. 0 to 6, what is the farthest left? And so you take the derivative, which is the velocity, and the velocity gives me critical points of 2 and 4. So I want to know what is the position at 0, 2, 4, and 6. Now my problem right now is I don't have straight up a position formula. I have something freaking close with the integral of velocity. So right now I have an approximation 1/3 t to the third minus 3t squared plus 8t. But then, because I'm taking a definite, or excuse me, an indefinite integral, it creates this c, but I think they give me a value to work off of. Yeah, s of 1 is equal to 4/3. So s of 1 is equal to 4/3. So this is what, 1/3 minus 3 plus 8. And I'm going to take 4/3 minus that answer. So the position is 1/3 t to the third minus 3t squared plus 8t minus 4. All right, so my position at time 0 is -4. Position at 2 is 8/3, which is 2.6667. Position at 4 is 4/3. Oh, excuse me, 1.3333. And then the position at 6 is 8. So when is it the farthest left? Again, negative is left, positive is right. So it is the farthest left at time is equal to 0. I think the answer in the book says time is equal to 4, because what they were doing is we see that position would be maximized and then minimized right there. However, that's a relative minimum, not an absolute minimum. So because they say, when is it the farthest, I'm going with the absolute, which you have to use the criterion test. That's it.